Good morning. My name's Gary. I've put this little video together to show you where we're at with our shaker table building article we're posting at a couple of the discussion forums. Most of you who've downloaded part one recognize this little prototype table in front, which illustrates the basic concepts of a link type table so it could be set up as a flexi table. We've now moved beyond this little scaled model into a larger full-size prototype where we can check the engineering of the drive system and make sure the thing actually works. That's basically a frame. It's made out of 1x2 poplar. It's not extremely strong. It needs a significant amount of further work to refine it. If you look down here in the mechanicals, you can see I haven't added any of the belt tensioners yet, so the belts are actually quite loose. And the table also does not have the upper frame installed. This assembly that's on here right now is temporary, only so I could check the geometry of the drive rollers. This entire assembly will be replaced eventually. I worked on this last night, and as you can see, I tried to use 2 paint sticks as my spring. They aren't quite strong enough, so I added a couple of bungee cords on here for today's demonstration. The rear adjuster spring is still just a jury rig at this point in time, though it actually works, which amazes me. This is my surplus World War II motor. If you touch it while it runs, you'll get electrocuted. That's the basic table. This is a typical link. The links aren't installed, but when the table's finished, they will fit inside the frame, and they'll carry the deck suspension system itself. You can build this table with flexible strips, very similar to what you see on the popular Gemini tables, though I really like the links myself. The drive mechanism we have in here right now is what I call the worst case scenario. It's large and very, very bulky. To give you an idea of what happens is the motor turns the crankshaft. This large roller wheel intercepts these other 2 wheels and cause the tabletop to move. And as you can see now, only one wheel is engaged, because with this type of a drive system, by adjusting this spring back here, you can create either a bumping table or a jerking table or actually an oscillating table. This is probably one of the best drive systems that you can find. A refinement on this system uses this eccentric, and I showed how to make the eccentrics in part 1 of the article. This will give a much smoother motion to the table, and the stroke can be adjusted anywhere from 1/4 of an inch to as great as 1 inch. The same situation applies to this large roller. The stroke can be adjusted from 1/4 inch to 1 inch, though this one will provide the roughest bounce, considerably rougher than the eccentric will. Right now, I've got this set up for a very low RPM. This particular model is running at 214 RPM, and it uses the largest pulleys you'll find on most shaker tables. So you can see if you use smaller pulleys to push the RPMs up to around 280 to 300, you can actually build a smaller frame than this. So this particular frame is only 30 inches long and 16 inches wide, and it can handle a table deck as large as 3 feet by 6 feet or as small as, say, 2.5 feet by 3.5 feet. I've got this one set up. Eventually we'll be running a 2 foot by 4 foot tabletop on this. I'm going to go ahead and fire the machine up, and believe me, it's extremely noisy. It's not bolted down, it's not clamped down to anything. The rollers we have in here right now are just real cheap $3 hardware store plastic rollers, and they're not tightened, they're bushings. As a matter of fact, nothing is tight on this machine right now, so it will really make quite a racket when it's running. Hopefully it won't beat itself to death and we won't have pieces of hardware flying into the camera. So here we go. Hang on to your hats, and we'll set this thing in motion and hope for the best. I don't know if you can hear me over the racket of the equipment, but you get an idea of what's happening here. Pretty noisy. The amazing thing about it is that it actually has very little vibration that's transferred down from the frame into whatever base you set it on. This table you could put on the tailgate of a pickup truck and use it in the field if you had a power source. You can always set this up with a 12-volt motor, preferably a variable speed drive. Right now this is set up, as I say, as in bumping table mode, which gives the most hardest impulse of either of the three settings. I have this rebound spring set up right now. I can't easily change through the three settings, so that'll have to wait till another video. And I'll also install the small eccentric cam in the machine, which will really improve it. This same concept can be used with a conventional cam. And we showed that in the first part of the building article. So you can set this up to operate as a standard old-fashioned bumping table very, very easily. From start to finish, including all of the small-scale mock-ups that I did, we've got under $250 invested. I think we're at about $244. I anticipate once I make all of the refinements and build the deck, we'll probably have around $350 invested for a table that actually operates very good, even though it still needs fine-tuning and refinement. This is a very good start for somebody that wants to put together a shaker table that has a lot of potential flexibility. So thanks for your patience on watching this little video.